Assalamualaikum and a very good day. Happy to Dr. Azana and friends. Today we are from group 2. We're going to present for the lab report of experiment part, which is stability of floating body. These are our group members. We move to the introduction part. So the stability of floating bodies is a fundamental concept in fluid mechanics that deals with the equilibrium and also the stability of objects, partially or completely submerged in a fluid. According to metacentric principle, the relationship between the location of the metacenter and also the center of gravity will determine how stable a floating body is. The intersection of the weight force line of action and also the vertical line that passes through the center of buoyancy is known as the metacenter. The body is said to be stable if the metacenter is above the center of gravity, since any disturbance will result in a restoring moment that returns the body to its initial position. So for this experiment, the stability of a ponton is determined with the center of gravity at different heights. The objective of this experiment is to determine the height of the metacenter using the tilting method. For theory part, we use shape as an example to show how metacentric height will be determined. So, in order for stable equilibrium to occur, if one is placed, it will return to the equilibrium position. And if the center of gravity, which is G, is below the center of buoyancy, which is B, a rotating moment will be produced and the body will tend to return to its equilibrium position, as you can see in figure 1b. And unstable equilibrium will occur if one is placed, it returns to the new equilibrium position. If the center of gravity, which is G, is above the center of buoyancy, which is B, and overturning moment is produced, and the body will be shown as in figure 1c. These are all the equations that will be involved in this experiment. For the first equation, the overturning couple, which is is equal to mgx, which we know that mg is equal to w, so it will form wx. So for the rotating couple, which is cr, is equal to the mg times with gm, which is the height of the metacentric, times with the tan theta. And for the assumption of the equilibrium condition, C naught will be equal to the CR. And then we will get the final equation which is in form of the metacentric height equal to Wx divided by W tan theta. And for the equation 2, metacentric height is defined as Vm, which is the height of the metacenter above the center of buoyancy, minus with Bg, which is the distance between the center of buoyancy and also the center of gravity. And then we substitute the value of Bg, it will form the y plus d over 2. Y is the center of gravity, while d is the depth of water submersion. And then for the equation 3, it will correlate with the equation 2 as well. As we know, Bm, which is the distance between the center of buoyancy and also the metacentric height, is equal to the IWS. IWS is the second moment of water surface area at the vertical axis, divided by the volume of the water displaced. For the equation 4, it is also the same. It correlates with the equation 3 as well. IWS, which is the surface moment of water surface area, will be equal to the LB cube divided by 12. And then the last equation is equation 5. V. V in this form is the volume of the water displaced. It will be equal with the W, which is the mass of horizontal weight, divided by the density of fluid.
So this is the experimental setup for this experiment. So for methodology, first, this experiment setup is shown as in figure. Second, the horizontal weight will be removed and the height of the vertical weight on the mass of the pontoon is fixed. Third, the center of gravity will be determined by putting the pontoon mass on the pontoon stabilizer. The length of the center of gravity will be measured, which is the half distance from the base of the pontoon. The center of vertical weight on is fixed. Fourth, the horizontal weight will be fixed and the thread is ensured to be at 0 mm position with no tail. Fifth, the tank will be filled with water and the pontoon will be placed in the tank. Six, the length of the pontoon which will be submerged in the water will be measured. 7, the horizontal weight will be moved 20 mm to right and the angle of tilt of the thread will be recorded. 8, step 6 will be repeated by moving the horizontal weight to the right with 20 mm increment. The angle of tilt will be recorded. This step will be repeated until the plumb bob which is hanging on the thread touches the side of the pontoon. 9, step 6 and 7 will be repeated by moving the horizontal weight to the left. And lastly, the height of vertical weight will be adjusted to the new height, which is middle, and step 1 until 3 is repeated, followed by step 5 until step 8.
Result. This is the result that we get during the experiment in the lab. Discussion. Plot the graph of GM versus theta and determine the value of GM from the plotted graph when theta equal to 0. So we have the table here, which is we have angle and GM. Angle we get during the experiment. So we have a negative sign, which is referred to the left side, and positive sign referred to the right side. GM we need to calculate using the formula. So from the graph, we can see the plotted line intercept with the y-axis, which is theta equal to 0. So we get GM equal to 0 0.5. Okay, we continue with the test 2. From the experiment, we get y-intercept, which is GM equal to 0.0875. From the test 3, we get that GM equal to 0.1063. So the second question, we need to calculate the value of GM for each test using an area of second moment, compare and discuss the obtained value with the value of GM from 1. So to calculate this, we need to use the equation of PM equal to IV, which is I inertia, and V equal to volume. And then we need to expand the equation so we can get LB power of 3 over 12 divided by mass over density. So in this experiment, we get that Bm equal to 0.1949. So to find Gm, to answer this second question, we have this several equation, and then we have Gm equal to Bm minus Bg, which is Bm we already determined with the previous slide, and then we have to find the Vg. So we know Vg equal to y minus d over 2, and then after the calculation we have the test 1, gm for test 1 equal to 0.0699 meter, for test 2 0.1149 meter, and the last one test 3 0.1249. So from the previous calculation, we already get the gm theoretical and gm experiment. So we can compare both uh, value by find the percentage error. So we have the percentage error equal to GM theoretical minus GM experiment over GM theoretical multiply by 100%. So for test 1, we have 28.49, test 2, 23.85, and the last one, 14.89. And the last question, discuss the reliance of metacenter on the position of the center of gravity in terms of stability of the floating body. So we have three types of equilibrium for this floating body. First, we have a stable equilibrium. When the metacentric M is above the center of gravity G, it will create a positive metacentric height Gm, ensure the stability. When tilt, the center of buoyancy B shift, but the metacenter stay fixed. This creates a righting moment, which help the body return to its upright position. Positive GM ensure the stability of the floating structure, preventing capsizing and maintain the equilibrium. Next, here we have neutral equilibrium. So, neutral equilibrium is if the metacentric M coincide with the center of gravity, the body remain in its neutral position without returning upright or tilting further. This happens because no righting moment is generated, and the force acting on the body are balanced. The body is neutrally stable with neither the stability to correct itself nor the instability to capsize. So the last one here we have unstable equilibrium. If the metacentric M is below the center of gravity, the body continues to tilt instead of returning upright. The righting moment acts on the opposite direction, worsening the tilt and increase the risk of capsizing. Ensuring the metacentric is above the center of gravity is essential for stability and preventing instability. Lastly, for discussion, discuss the effect of variation in angle of tilt on the position of metacenter. Variation in tilt angle affect the position of the metacenter and the stability of a floating body. At small tilt angle, the center of buoyancy shift linearly and the metacenter stay roughly fixed. The stability is straightforward. with the writing moment proportional to the tilt. However, at large tilt angle, the center of buoyancy shift more as the submerged volume change and the metacentric move lower, reducing the metacentric height. This decrease GM weakens the stability, increase the risk of capsizing. If the tilt continues to grow, the metacenter may drop below the center of gravity, cause GM to become negative, which leads to unstable equilibrium. The body will continue tilting instead of returning up, right? So in this experiment, GM decreased with increased tilt. Show that stability is highly dependent on the angle. A graph of GM versus the angle demonstrate that the higher angle, GM drop more sharply, indicating reduce the stability. In conclusion, as the tilt angle increase, stability decrease, and the body may transition uh, from stable stable to unstable equilibrium if GM becomes smaller or negative. Conclusion. In conclusion, the stability of a floating body is determined by its metacentric height. In this experiment, high GM value corresponding to greater stability. The data indicates that GM value are higher at small tilt angle and decrease as the tilt angle increase, suggesting reduced stability at larger tilt angle. Additional, the tilt angle increase with the distance of x of the applied force from the center line. For both left and right tilts, the tilt angle reach its maximum as the force is applied further from the center line, demonstrating a direct relationship between the distance and the tilt angle. This is our references. That's all from us. Thank you.